We're going to spend some time talking about how to balance chemical reactions. This is inevitably a part of almost any chemistry course. We won't spend too much time on it, and I hope to give you some good leads on exactly how to do this. You actually won't be required to do it very much in this course, but I want you to be aware of how it works so that you can balance reactions when you need to in future applications. So our learning goals are going to include ensuring that there is conservation of mass in a chemical equation. That's why we balance equations. And I'm going to talk about the tree trunk method for balancing equations. There's other videos in the lesson that also talk about this, but we'll give it a quick run through and show you a couple of examples so you can learn how to use it. So the law of conservation of mass. Well, since reactions are really about valence electrons changing their stable state, we're not actually creating or destroying any atoms in this process. So the total mass of a reaction mixture has to be unchanged. It cannot be altered at all during the course of a reaction. So, for example, I may look at a skeleton equation that involves the reaction of nitrogen with oxygen to form nitrogen monoxide, NO. Okay, this is the skeleton equation for it. And knowing that I can't create or destroy any atoms as part of the chemical process, all I'm doing is rearranging the electrons, I would look at this and say, well, I've got 2 nitrogen atoms on the left-hand side and 2 oxygen atoms on the left-hand side, but on the right-hand side I only have 1 of each. So there's something that's not quite right. I'm missing some matter that should be there. So what we're going to do is we're going to adjust the coefficients. Now, what do I mean by coefficients? I'm talking about the numbers that I multiply these molecules by in the chemical equation. So right now they're all implicitly 1. So there's effectively a 1 before the N2 and a 1 in front of the O2 and a 1 in front of the NO. I want to change those 1s to numbers that allow those atoms then to balance. Now, I've made a point here of saying it's changing the coefficients, not the subscripts. The subscripts 2 and N2 and O2, they actually tell us about the identity of those molecules. If I change the subscript, I'm changing the chemical identity of the stuff that I'm working with. So I cannot change the subscripts. I can only change the coefficients to balance an equation. So I think it's pretty obvious that to balance this one, this is a particularly easy one, I just need to put a 2 in front of the NO, and now I've got 2 of each of the nitrogen and oxygen atoms on both sides of the equation. The way you would check a balanced equation, or way you would check a chemical equation to see if it's balanced, is you go through each of the elements and make sure that there are the same number of atoms on both sides of the equation. All right, so let's see if we can develop a method for doing this more systematically. Now I'm going to use some pretty easy examples, but in principle you can use this same method no matter how complex the reaction is. Now I'm going to do a slightly different reaction than the one we just looked at. This is the reaction of nitrogen with oxygen to form nitrogen dioxide. So we're now making N2 plus O2 going to NO2. NO2, as I usually will say at some point in the class, that's basically smog. So the brown air that you see when you have a lot of smog over a city, that's NO2. So the way we do the tree trunk method is we create a tree trunk. This is it. And inside the tree trunk, we're going to list each of the elements that appear in this equation. Now, this is a particularly simple equation, so I only have nitrogen and oxygen. Now, I want to specify how many of each of these atoms there are on each side of the equation. So I look at the left side and I say, well, N2 has 2 nitrogen, so I put a 2 there. And on the right-hand side, NO2 only has 1. Well, I already have a problem, don't I? Okay, when I do oxygen, O2 has 2 oxygens, but NO2 also has 2 oxygens. So O looks okay. So I want to do something to make nitrogen balance. And to do that, what I'm going to need to do is multiply NO2 by the number 2. I'm going to have to change its coefficient to 2. And so when I do that, I'm going to convert that 1 into a 2. But at the same time, because there's oxygen in that molecule, I'm also going to convert that 2 into a 4. So now I've messed things up for oxygen. So what do? Well, now I've got to take a step to make the oxygen balance. Okay, now since the nitrogen is balanced already, all I need to do is make an adjustment to oxygen, and the way I can do this most simply is to multiply the O2 by the number 2. I'm going to change its coefficient, and when I do that, I will change that number from 2 to 4. Now I can see that both nitrogen and oxygen are balanced on both sides of the equation, so I have a balanced chemical equation, and this is what it would look like. where I've multiplied NO2 by 2 in the first step, that's now shown here, and I multiplied O2 by 2 in the second step, so that's shown here. So I've just summarized basically the steps of doing this. So now I want you to try it. You've learned how to use the tree trunk method, so I want you to try it for this synthesis of ammonia from nitrogen and hydrogen. So you might pause the video now or review the last slide and try this out and see if you can balance the equation. All right, hopefully you've had a chance to do that. So let's go through the tree trunk method for ammonia. Okay, here's our trunk. We have nitrogen and hydrogen this time. Nitrogen has 2 N's on the left-hand side. It only has 1 N on the right-hand side, so very much like the NO2 example we just saw. H2 has 2 hydrogens on the left-hand side, but it has 3 on the right-hand side. So it's not balanced to begin with, like oxygen was in the previous one. Okay, our first step is going to get N to balance. So we're going to multiply the ammonia by 2, so that converts that 1 to a 2, but it also converts the 3 hydrogens into 6 hydrogens. You always have to apply that to both of the constituents of that molecule. All right, so now hydrogen is really out of balance. I got 2 on one side and 6 on the other. To get those to balance, I'm going to have to multiply H2 by the number 3, so that I'll have 6 on that side. When I do that, now I have both nitrogen and hydrogen balanced, so my balanced chemical equation is going to look something like this. All right, I've used a couple of very simple examples. I want you to get the principle of how to balance equations. It's not my goal to make you balance the most difficult equations there are to balance, but to understand how this works and that we need to do it, because if we don't have a balanced equation, we have something that's not right in nature. We have an expression of a chemical process that is creating or destroying atoms, and we can't do that. All right.